MIT has always had that problem.
But I want to tell. I'd love to hear more about your Echo Bridge stuff.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Welcome everyone to Charlotte IoT. I'm stoked to see so many awesome geeks and other people too. Well, actually everyone's awesome, so really stoked to have you at our meeting. And Charlotte IoT now, we've been around for I think close to 5 years, and we're growing a lot still after 5 years. And we've done 71 meetings and almost 1,600 people. And the reason we're doing so awesome is we're focusing on like technical content, and we're doing hackathons, and we're for everybody. It's not just like the wizards of IoT, but the newbies and the makers and everybody. and our students too. So we want everyone to come to our meetings and enjoy the goodness. This board here is amazing, and this is really the reason why this group has grown so well. All these people here contribute to do things like swag and hackathons and video streaming. And stand up for a second if you're on the board. So these are the awesome people who make everything happen. Thank you, guys. And we have Facebook and Instagram, and we always love it when people post things and say awesome things about our group. And we also are streaming on YouTube. And so if you missed the meeting, you can watch it on YouTube. But what's really cool is, like, tonight is going to be awesome. You can watch it 10 times or however many times you want to. They're just really good. And if there's something that you just didn't quite get, go back and watch the video. It's great. And I want to thank Joseph for doing our streaming on YouTube. And he's amazing. He just, it's like first-rate productions. And you can also like hire him to do commercials, to do video productions, and things like this. And if you need someone, then I highly recommend Joseph. He's like incredible. And you can check out his work on the Charlotte IoT channel. We have Slack. Yes, Mike.
Just to comment, regarding YouTube, we're trying now, testing some code to integrate messaging from YouTube so that it comes over to Slack so that Joe can put some of the messages and questions from the other group in Davidson up on the video.
That's awesome. Maybe we could just do Slack directly, like they can just type in Slack too.
We can do that. There's definitely a channel that's going to be used, the YouTube channel. It'd be good if we use one channel for Q&A during the live meeting. So everybody use that if you've got messages tonight.
Yeah, very, very cool. Slack is a great place. If you guys have questions, you want to ask senior people, go to Slack. There's channels for different types of things, machine learning or our hackathons and that type of thing. So we have like over 400 people on Slack, so it's really growing and doing well. And thank you, Mike, for setting up that integration. So our sponsors tonight, my company is Pratt Miller, and Graham is here with Snap AV, and I've got slides on both. So let me. You want to get up and?
So welcome. Thanks for coming. How many first timers? You want me to stand?
Give us that, Dan.
Yep. Yeah.
I will stand next to him. How many first timers? So I've got a few. All right. So Snap AV, company-wise, we are a manufacturer that makes a bunch of audio-video products. About 3,000 different SKUs, and about 4 years ago, we launched a platform called Oversee, which I am responsible for, that manages all the products that get installed into people's homes and small businesses. And today we have about 3 million or so of the devices in the upper left-hand corner of our products that we manage.
Did you say 3 million?
We're at 3 million. And I checked the numbers today. We will hit 200,000 locations in about a week and a half. We're at 197,000 locations. So platform has really grown significantly. It's a great group to work with. I have about 30 people on the team, and we've been hosting this from
the beginning, almost
a number of years. So it's been great. So welcome everyone. If you have any questions, I'm happy to answer.
Yeah, thank you, Graham. Snap AV is just incredible. And are you guys hiring?
I filled the last position. I'll have another one open in June. So a couple more months, and we'll start looking again.
Yeah,
DevOps primarily is what we're looking.
Everyone's looking for DevOps.
Yeah.
Yeah. So if you're in DevOps, you're in the right spot. My company is Pratt Miller, and you guys know me as Logical Advantage because we've been Logical Advantage for the last 15 years. But our company merged in, and we're now part of the Pratt Miller family, and I'm like stoked to be a part of a much bigger, cooler organization that does like epic projects with racing and motorsports and defense and like really big IoT opportunities. So we're like really stoked to have all this come to us. And well, that's really, I've got some examples of some cool projects, and I'll skip through this because you've seen that slide before. And let me just talk about some particle things since Particle's speaking tonight. And here's one we did for a thread manufacturer. And I've spoken at Charlotte IT before, but we made a PCB that's monitoring spindles that are spinning around. This is using the particle P1, and we started off with a prototype using the standard particle photon, and then we made the PCB board that uses the module as a system on a chip that works out really well. And we built this thing super fast. Like our prototype was a matter of 3 months or so, where we had it working, pushing data into Azure, and to where we could get visualizations and data and things like that. Here's another one that we're actively working on now. That's for a company that makes stretch wrap, and they have a value add of knowing where the stretch wrap's applied to the pallet. And we're using LiDAR that can look at the floor to know when it's made a revolution, and it also knows the height. So it knows how many revolutions are made at the bottom of the pallet, traveling up, and at the top. And it's using this to make safety data, and if there's like a spill in a truck or something like that, then we'll tie that to the data, and then they know how the pallet was wrapped, and they can change the algorithm for how the pallet's wrapped to make it more stable. And it's another example of how IoT can be used to drive value in ways that a lot of us haven't really thought about. This is a safety issue, and they sell stretch wrap, and they have an IoT solution they apply to existing machines. But it's really cool, and what else is really cool about this is we're using the 3rd generation particle stuff, the mesh stuff, and Brandon's going to be talking about this tonight. And because we're using mesh, we don't have to run a whole bunch of wires connecting things. So we've got something on an arm that's spinning, that's one microcontroller, and then we have another microcontroller that's reading like a proximity switch, and then we have an HMI, and we're able to talk without having to run wires. And so this means a much quicker implementation to where there's a lot less travel time. They can install it. They can do like a really quick demo with, this can be on like a magnet. They can attach it and just give it a battery for a sales demo, and it can start showing data and things like that. So the particle platforms really made us be able to implement this quickly, and then we can turn it into an enterprise solution, just like we did with the service thread, where we made a PCB board and whatnot. But for our first iterations, we did breadboards, and then we're doing like off-the-shelf components with I2C buses and optical isolators and things like that, so that we're having a really quick iteration on our builds and whatnot. But I'd love to talk to you guys more if you want to know about like how we use particle and how awesome it is. And Brandon too. I'm like so stoked that he came tonight, because particle is our go-to, and we've done lots of hackathons using particle, and we've done lots of talks using particle, and it's just so easy to learn, and so many people in this room have made really cool things. Clint made this really cool mechanical turkey that he can control with a phone, and is used as like a decoy. Is that what it's called?
Yes, sir.
Yeah, and did you make that? You sell that commercially?
Well, I started doing that, and then I kind of have to pull back a little bit, but yeah.
But it's still really, really cool. And there's others in this room who are entrepreneurs, and like particle is a really good platform to pick, because it's so easy to get data, push it in the cloud. If you want to integrate it with Azure or other clouds, it's really easy, and they make it easy, and they have ways you can deploy it to groups of devices, and over-the-air updates is like beautiful. Like I first found out how nice over-the-air updates were on Christmas. I made this 20-foot tree that's outside with all the lights, and it's like cold and raining, and I'm sitting in front of the fireplace programming it, and I'm like, oh my God, over-the-air updates are beautiful. You don't have to be out in the cold. But like for this project, it's beautiful too. We had an issue where one day it didn't connect to Azure, and one of the machines lost a day's worth of data. Well, rather than having to travel out there, we were able to update the code so that when it can't connect to Azure, it just does a reboot, and then it just keeps working. But if we had to travel there, that'd be expensive. I mean, 2 hours there plus updating the machine. And so over the updates are the bomb. And it'd be even more valuable if we made more bugs, but we haven't had to deploy it too often. But it's still like really nice to know that it's there. Oh, and we're looking for DevOps people always. So if you're in DevOps, don't talk to Graham or Jeremy.
Not till June.
Yeah. And we're now streaming to Lake Norman. So there's a whole nother group, people north of town who, it's really bad traffic to get here. And so we're streaming there. And they're also hosting other meetups in addition to the Charlotte IoT meetups. But we want to do things to include them. And Mike was talking about Slack integration. I think that would be really good where they could ask questions and be more involved in our group. So we've got tons of events coming up. And this next Lunch and Learn is going to be a very technical one. It's about edge computations. So you can build like machine learning models in the cloud, and then you can execute and make the predictions on the edge. And this Lunch and Learn is all about that architecture and different ways you can pull off edge type things. So that's a great one if you're a technical person or you're in IoT and you want to learn more. That's at the Launch Factory, which is a new location for our Lunch and Learns. And it's a really great, nice location that has like lots of really good parking, and it's really close to our office, so I'm kind of happy about that.
That's in Charlotte? Dan?
Yeah.
Is that in Charlotte?
It's in Charlotte, yes. Sorry. Near Wilkinson Boulevard.
Okay.
And then, good question because I've got others from other cities. Atlanta is the next big Riot meeting, and Riot meetings usually have hundreds of people, and a lot of their meetings are focused on marketing and business and less technical, but some of them are technical as well. This one is going to be on IoT for like stadiums and sports and things like that. And so I think if you're like interested in sports or an IoT, this would be a great meeting to go to. And Helium is our next Charlotte IoT meeting, and it's another one that you won't want to miss. And raise your hand if you've heard of Helium. So raise your hand if you're here last month for the LoRa meeting. So Helium is a competitor to LoRaWAN, and what it's for like networks in a city. And Charlotte's one of their target cities, and it's a distributed network that uses blockchain. And people will put up their own access points on the Helium network, but it's low power, just like LoRa is, and it's great for things like scooters and things like that you don't want to be on cellular to drain your battery. And we're thinking about doing a hackathon around Helium also, and not the next hackathon, but one of the future ones. So it's going to be a really great meeting, and you won't want to miss it. They're coming in from San Francisco. And Startup Pitch Night is the 10th, and that's in Raleigh. And those meetings are always really good. They just had 7 teams that went through the accelerator program, and this is like what they produced at the end of the accelerator program. And if you're an entrepreneur and you like to get ideas on like what are other people thinking of and doing, these meetings are really good to go to. And then Jeremy, I'm going to talk about the hackathons.
The next hackathon, we're going to take a new approach.
Standing for the microphone.
So we're going to take a new approach, and we're going to be building out a game, and that's going to, sky's the limits on this. So we've got a number of 5-meter RGB LED strips. We've got sensors, we've got all kinds of things, big buttons. Basically what we're going to do is start building out a game for the next Maker Faire, and want something that we can get more people attracted to not only Maker Faire but also to our booth. And so this is kind of a conglomeration of what we can do with these things. Looking for people who can program, looking for people who can't program, who can strategize, creative people who can say, hey, when somebody walks up to the table, maybe the game should have a different flair, or maybe that should slow down movement in a specific area of the chain of LEDs or something. Interesting ideas where we can say, let's actually build something that is more than just Pong. you know? So, yeah, it's going to be real great. It's going to be March 30th, 9 o'clock in the morning. I'm at Lending Tree, and they've always been great to give us a little bit of space there. We are going to be using particle, so it's either going to be particle, but probably particle mesh, because we want to control from both sides, and so we're going to be working with that. We've got all the hardware, so you know, basically looking for people who are interested in coming and doing something fun. Yeah, it's going to be great. The biggest and best part of that, though, is we take what we learn here, right, and we get to apply it in these hackathons. So it's really a good chance to come and say, I don't know anything about particle. Let me learn what particle is, right? I don't know anything about, you know, what we're doing with, you know, what's an RGB LED? How do I control it, right? I'll show you, right? And talk about game strategy, stuff like that, things that I'm not that good at, right? So you get all these people together and have all these ideas, and it just becomes something that is pretty awesome. So yeah, come out. It's going to be March 30th, 9 a.m. We'll put it on the website, and hope to see you there.
Yeah, awesome. Thank you, Jeremy. So the Maker Faire is like totally epic. It's in October, and we want to help grow this event and make this like even bigger and bigger. So if you guys are makers, be thinking of October, and we'd love to have you at the Shot.IT booth. But if you want to have your own booth, I can hook you up with people with the Maker Faire. It's too early to register, but just be thinking about it because we want to be epic and get other groups involved too. If you are like active in other maker spaces and things like that, then make sure that they all know about the Maker Faire. And then the awesome part of the meeting tonight's Brandon, and I can't say enough about how cool the mesh stuff is. It's been so beautiful. They've got, I'm going to steal your talk, but you can't help but to talk about it because they've got Xeon devices, which are just like end nodes of mesh networks, and they've got Argons, which are on Wi-Fi gateways, and then Borons, which are cellular gateways. So there's nothing easier. I mean, IoT has never been this easy to make like really cool stuff so fast, and then having over-the-air updates and things like that is just like beautiful. And we really appreciate you coming tonight.
Yeah.
Thank you, Brandon.
Great. Thanks.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life. What is the Internet of Things? Is it hardware, software?
Everybody, and thanks so much, Dan, for that introduction and for the wonderful testimonial for Particle. I feel like I can cut about 20 minutes out of my presentation. Well, no, I think it's great, and I appreciate it. Like the slide mentioned, I flew up from Austin this morning. It was 26 degrees when I got into my truck to go to the airport. So thank you all for giving me a chance to get the hell out of there for a couple of days because it's like unseasonably cold, and I'm a Texan, so 26 degrees is like 40 below to me, or it might as well be. I couldn't stand it. Y'all are streaming, which is really exciting. This is actually, I'm seeing this more and more at groups. I feel like I have to, by extension, mention that I have also started streaming a couple of months ago. I stream on Twitch twice a week on Tuesdays and Thursdays, and typically I'm not streaming playing Fortnite because no one would watch that. What I am streaming, however, is the kind of work that I do for Particle during the day, everything from IoT builds to setting up Azure pipelines for doing builds automatically on check-in to working on firmware, building websites that talk to the Particle device cloud, all this kind of stuff. I am a full stack IoT developer, so I do everything from hardware, firmware, websites, the software side of things as well. So you can find me on Twitch, same as my Twitter handle, Brandon Satrom, all one word. If you're interested in watching that, it's a fun time, and I love to get derailed. So I did a stream yesterday because I was flying today, and I must have let the chat room derail me 5 or 6 times, all kinds of random stuff. So feel free to join that. I'd love to see you there. I'm going to spend some time tonight talking about building awesome IoT apps with Particle. Very briefly, what I do at Particle, I'll explain it. I mean, I have the greatest job in the world, I think. I get to spend my days building cool stuff so that our community, so that you all, so that hundreds of thousands of developers out there can build even cooler stuff. And then help make our products better so that we can all build the coolest stuff around. Every product has rough edges. Every new piece of technology has issues in the wild that we discover. I work with customers. I find some of those issues, but I work with you all to find those issues and really make our products as good as they possibly can be. So what I want to talk about tonight, I'm really structured in 3 parts. One is introducing the Particle platform. Even if you're familiar with us and know a lot about what we do, you may not be familiar with sort of how our philosophy, how we've evolved over the last 7 years. So I'm going to spend some time talking about Particle in general. I'll talk about a bit about the Particle device cloud, what we think to really be part of our secret sauce as a platform, and Dan hinted at some of this a little bit with things like OTA and also the mesh capabilities. And then finally, I'm going to spend probably the balance of this talk talking about mesh networks, talking about why we even went down the path of creating new hardware and building mesh networking in those devices to begin with. So the way that I like to describe Particle is that we are a full stack IoT device platform. Many people know us for our hardware. Folks in the maker community know us for hardware, but really, we think what makes Particle special, what makes us special is not just that hardware, although we're big fans of the hardware that we create, even more so now with the Feather-compatible 3rd generation devices, but we also focus on connectivity. We got into this business seven years ago because connectivity was hard. Anybody may remember, if you've been in this maker game or this IoT game long enough, you may remember that 7 years ago, the state of the art for a connected hobbyist prototype was a $35 Arduino Uno and a $65 Wi-Fi or Ethernet shield. So you're in for $100 just to get something connected to the internet that long ago. When Particle introduced the Spark Core, now 6 years ago, 5-6 years ago, that was a sub $40 dev kit. That was really the first example of what we have built our ethos around of creating easy connectivity, then expanding into cellular and now with mesh. But behind all of that is an IoT device cloud and then web and mobile app SDKs and integrations that make app development easier. That last piece really cannot be undersold because a lot of our customers, a lot of developers come to us not as hardcore IoT experts that are really designing their own embedded boards, designing their own custom ASICs and all this kind of stuff. They're people that are actually coming to us from other backgrounds. They're web developers or mobile developers that are trying to solve a connectivity problem and coming to the Particle platform. That was how I came in through the door with Particle and how many of our customers have as well. So having those easy integrations and SDKs is really part of what we think makes Particle special. So over the last 7 years, we've grown into the world's largest IoT developer community with now close to 170,000 developers since I last checked, with over 500,000 devices online. And what's really driven us over the course of the last 7 years, and if you think about this space, the IoT space over the last 7 years, we've really gone through a roller coaster, the roller coaster of the Gartner hype cycle with the IoT. And Gartner actually would argue that we haven't even gotten to the worst part in the trough of disillusionment in the IoT, which is kind of crazy to think about. But all of you are here because you believe that we will actually make it to the other end. And Particle obviously believes that as well. Over the last 7 years, we have experienced a lot of those cases of IoT connectivity being used as a solution in search of a problem, right? With connected toasters and other devices that really feel like, okay, this is great. You're putting a Wi-Fi chip in something, but doesn't actually really need it. Our customers have really driven us down this path of solving real problems. The folks that we have worked with, and Dan just gave a couple of really great examples. I mean, the balance of the work, not the stuff that's getting written about on Engadget, the stuff that makes it on the front page of BuzzFeed, but the balance of what's happening in the IoT space are those real problems that are being solved, where you're taking older industries or where you're taking disconnected solutions and you're adding that secret sauce of connectivity and doing something useful with sensors and actuators that you couldn't do before. And so you can see in our development over the last several years why we've made some of the decisions that we have, because it's been in response to customers asking us for help. When we started with the Spark Core, really the thought was about how do we enable Wi-Fi for makers? How do we enable Wi-Fi for hobbyists? But we had a lot of customers, and Dan and Logical Advantage is a great example of a customer that said, hey, this is great, a dev kit is fantastic, and sure, you can sell me a version of this with castellated edges that I can solder right down onto a PCB, but I'd really like to design my own custom PCBs and use your modules. So give me something for mass production. I don't want to put your dev kit in my mass production product. And so very early on with the Photon, after releasing the Photon, we went down this path of making sure that we had a way that a customer could not just prototype with us and then move on to real hardware, as tends to happen sometimes, but prototype with us and then keep that same firmware, that same application, and move it into production and move it into mass production modules. In both of these cases, the P0, our smallest form factor, and the P1, which has the built-in PCB antenna that Dan mentioned for Service Thread, those are available in manufacturing-ready reels, and they can run the exact same firmware that you're running through prototyping. So now we started with Wi-Fi, and we had the same sort of pull from our customers that said, hey, Wi-Fi is great. We love that you guys have given us some great modules. We love that we have Wi-Fi connectivity really easy, but we're trying to solve problems where Wi-Fi is not readily available. So how can you help us with cellular? I wasn't at the company at the time, but I've heard stories that we thought, okay, sure, we'll do cellular. How hard could it be? It's really hard. One of the hardest pieces of doing cellular is the connectivity piece of it. We actually had to go through the entire process of registering Particle as a mobile virtual network operator, or an MVNO, and to create contract agreements with other providers so that we could get access to their cell towers. This is part of the reason why a lot of companies didn't pursue cellular at the time, because the infrastructure was there, but the infrastructure was owned by somebody else, and you had to negotiate to get on that infrastructure. But we've been successful with that and have been able to make cellular, we think, as easy as getting started with Wi-Fi, and still having the same model of having a dev kit, a breadboard-friendly dev kit, and the ability to actually take that exploration further with the E-Series evaluation board, and then finally the modules for moving into production. And then finally, the mesh, or our third generation hardware. And again, this was the same sort of thing where we were prompted by our customers to say, hey, this is fantastic. We love that you guys have Wi-Fi. We love that you have a cellular option, but I have, and this is fantastic, it's almost like it was planned that Dan mentioned this case here, but I have a solution where my devices are far enough apart that I really would like to, my solution is not one device, it's not one module, it's a number of connected devices. My solution is 17 devices that are spread across a floor, and they're not going to be running all the same firmware, but they need to be able to actually speak to one another. And so our idea with mesh and where we went down this path of creating the new third generation hardware was in helping customers solve those problems of distributing IoT solutions at scale, whether it's across a farm, whether it's across a factory floor, or even beyond. And the particle mesh devices from our third generation devices from a complete, like, let's talk data sheet stuff. This is the fun, really nerdy part of the presentation, but I love talking about this stuff because it's really kind of cool. We moved away from our old STM microcontrollers into the Nordic NRF52840 system on a chip, which runs an ARM Cortex M4, has a mega flash, Bluetooth 5, ARM trust zone cryptographic security module. It's got an NFC A tag, and really, most importantly, and what makes this whole thing interesting and the reason why we went down this path is that all three of these devices support IEEE 802.15.4, which is the open thread stack for doing local mesh-based networking, which I'll talk about in a few moments.
Are the photons moving to Nordic, or are they staying ST?
So the photons that we produce today are going to stay exactly the same. But when it comes to Wi-Fi, you actually have the option to either continue using the photon or you can use the argon as a standalone device. So that's one of the things that I'll demo today, is that just because these devices have mesh networking baked in, you can use the argon and the boron as standalone devices like you would the photon or the electron today. That's a good question. And so that's actually one of the things that I want to demo really quickly. And I didn't mention this specifically, but there's also the Feather logo on here. If you've bought anything from Adafruit, or if you've been to Adafruit's website in the last couple of years, you've seen that they're really big fans of the Feather form factor. We are too. We built our new hardware around the Feather form factor, which gives us the ability to be, gave us the ability to be immediately compatible with 50, I think now 60 to 70 different devices, from wings to other boards to screens, displays, other breakouts that actually are Feather wing compatible. And the argon is no different. So the argon, boron, and xenon all actually function in the same way. So I have a device here I'm going to demo in just a second. But this is actually an argon that's sitting in the Cricket robotics platform. The Adafruit Cricket is a platform that actually has a couple of motor drivers. All of these are on a single I2C bus, which is kind of cool. There's a NeoPixel display. There's 4 capacitive touch pins. Some GPIOs on here, 4 servo controllers. The thing is, it's a beast. It's a pretty amazing little board. And they have versions of this board that work with the Feather. They have a version of this board that works with the Circuit Playground as well. If you've ever used those devices, they're really good educational platforms for kids. But this device just pops right in and it works. It's pin for pin compatible. It works the exact same way. So to show you very briefly what I mean by that, I'm actually going to pull open a project that I have here. I'm going to go into light mode and I'm going to increase the screen size. Oh, hold on a second. By the way, if you have not yet heard of, if you use VS Code, Particle actually has an extension for VS Code now called Particle Workbench. So if you go to particle.io/workbench, this tool is fantastic. I've been using VS Code for years, and I was very, very happy to have this extension because it gives you all the capabilities that you're used to having in the Web IDE or in the old Particle Dev Atom-based IDE, and more. And also the ability to do local compile, which is fantastic. Okay, there is a command in here for changing my theme, so give me a second. There was a command for changing my theme. Preferences, color theme. There we go. Light. Is that better? Is that easier in everybody's eyes? Okay, good. I work in dark mode in my dark office and listen to dark metal music, and I don't really do that. So I have a project here that's using a couple of different particle libraries, the finite state machine library, Adafruit, and the Seesaw library that I actually ported into the particle ecosystem when we first started using this. And it's a very simple library. All it actually does is it pulls in the Seesaw. Seesaw is Adafruit's library for running I2C devices on the Cricket boards. And so I'm just creating a couple of states in my state machine, creating a new instance of the Cricket object, declaring a couple of motors, and then I have a couple of different states here that represent things like stopping the car, running forward, all this kind of stuff. There is no mesh capability inside this. When I set up my argon, I said I want to use it outside of a mesh network. So I'm just using it the way I would a photon today, except I have that Adafruit Feather compatible goodness in there. So I'm going to turn this on, and I'm going to plug it into the barrel jack, but I'm also going to plug it into the USB because I noticed when I got to the hotel today that the barrel jack, for whatever reason, the battery, it's not working to power the argon enough. So this is not going to rove on the floor, but you will see the wheels turn just as proof that this actually does work. Yeah, it works. So this is sort of the idea of running this, and it's a very simple demo, but this is really no different than if I were building. I could take this exact same code, and with the exception of a few particle dot commands that I'll show you, and I'll talk about in just a moment, this is the exact same code that I would run in the Arduino IDE if I was using an Adafruit M0 in here instead of using one of the particle devices. But the benefit is that I get everything else inside of the particle ecosystem, which is what I want to talk about now. And I just realized I should probably shut down Slack, huh? Yeah, let me do that before I get an urgent message right here. So again, you can use these devices in standalone mode, just like you would in any other device. But as I mentioned earlier, we really think that the secret sauce of Particle goes beyond just the hardware itself, but also everything else around the ecosystem. So not just the hardware that we create, but also the device OS firmware and the ability to very easily pull in libraries that make it easy to work with things like Adafruit Feather ecosystem, and then finally our device cloud and software tools. It would be impossible for me to talk about the power, our secret sauce in the device cloud without talking about my favorite and what Dan has already mentioned, and that is the over-the-air device capability. I love doing local firmware development. I love spending half a day trying to install a GCC compiler on my computer and then wondering why it doesn't work and having to pave the whole computer and start all over again, and I'm being sarcastic. That's actually a lot easier to do now, and Particle Workbench does give you the ability to do local compiles because we create a sandbox install of the compiler tools. But when we started down this path 5 years ago and first released OTA, this was a pretty revolutionary idea that you could actually create firmware. You could create embedded firmware using the GCC compiler, using Arduino wiring style C, and actually get a binary that's flashed to your device, and you don't have to install, you don't have to actually create a serial connection to your computer. You can just make sure that those updates happen where they need to happen. From a developer perspective in prototyping, that's really nice and convenient. But we usually have those devices close to us when we're working on development. But Dan had mentioned this earlier. When you're at scale, when you have devices that are deployed in the wild, when you have a product or a fleet of devices that need to be updated, that ability to actually push firmware updates OTA becomes super valuable the more devices that you add to the network. And you'll see it actually becomes really valuable in the context of mesh networking as well. But it's not just the OTA thing that's really valuable and that we like to talk about, but also our Particle Device OS and the firmware that we provide by default in these devices. Now we run a version of FreeRTOS, a real-time operating system that's very common across embedded microcontrollers, but we have a flavor on top of that, a device OS firmware that's open source. If you go to our GitHub repo, particle-IoT/device-OS, that is the firmware. That is actually the device OS firmware that runs on these devices. We take pull requests, we take criticism and comments and questions and all of those wonderful things. That actually runs alongside your user firmware and helps to manage the device itself, manage its connection to the device cloud, manage its ability to get online and exchange keys securely with the cloud, etc. And it also provides a ton of very handy features. 4 of these that we refer to as the particle device primitives. So those are particle functions, so the ability to actually expose a function on the device and call it from anywhere, from the device cloud, from a mobile app, from another web app, from another device. To actually fetch a variable remotely, so to actually get sensor data and make it easy for you to fetch that data from the device. And then pub/sub, to actually be able to send messages, events to the cloud, and then listen to events. And devices can actually listen to events from other devices, but you can also have the ability where non-device systems, web apps, mobile apps, console apps can actually listen to messages as they get streamed through the device cloud as well. And then on top of that, we provide SDKs for mobile and web development. And these are, I am by background and for most of my career, a web and JavaScript developer. And so I have spent many, many years, I was a Particle customer for about 3 years before I joined the company. And I spent a lot of time building web apps that interact with the Particle ecosystem and with those SDKs. And then finally, and this is worth mentioning, we actually late last year announced an IoT rules engine that's built on top of Node-RED. So extending not just the ability to give you a console to view device data, not just the ability to do pub/sub and call functions and inspect variables, but to add some additional intelligence outside of hardcore app development into your apps, where you can actually have, you can create sequences, Node-RED style sequences on top of your applications that inspect and ingest data, make decisions, backhaul that to other device cloud providers like AWS, Azure, Google Cloud Platform, etc. And then finally, the Particle Device Cloud and Console. And if you've used the Device Cloud in the past, yeah, question?
I know you guys are still in beta for the Node-RED stuff. And I understand there's a cost for it. I understand why. I've been looking at that. Is there an option to be able to get into that? I mean, willing to pay the cost, I would think there would be. Are you guys openly allowing people to subscribe to that now? Or?
Yeah, so the question was, we do have this Particle IoT rules engine. We announced it in October. It is in a beta right now. The question was, there will be a cost for it? Is it open and available for anybody to get into? If you go to our website, particle.io/rules engine, I believe it is, you can actually sign up. It is a closed beta right now, but you can actually, there's a registration form. You can sign up for it. If you sign up and you send me a message on Twitter, I can see about encouraging the team to get you access potentially a little bit faster. We are planning to make this generally available in the next couple of months, but we have not publicized yet what the pricing is going to be for it. Yeah. Ultimately, this is one of those things for Particle. It's a relatively new thing because what we want to be able to provide our customers with is it's a multi-tenant style deployment they're going to be getting. So everybody's going to have their own isolated instance of the rules engine that is unique to their account. And so we're still working through the specifics of how do we properly cost that so that we can manage the infrastructure to make sure that you get the kind of availability you need for that when it's hosted. And frankly, because this is built on Node-RED, I would be remiss not to say you also have the ability to roll something like this yourself. If you have the ability and the infrastructure to do so, you can run your own Node-RED instances on AWS. You can run your own Node-RED instances on a Raspberry Pi sitting in your office. And I've done that in the past as well. So that's also an option. And a lot of the nodes that we provide out of the box are also, there's open source equivalents of those that are available out in the Node-RED ecosystem. But yeah, if you go to that website and sign up, you can get access to learn more. And then integrations. I mentioned a lot of these integrations that I mentioned are actually made available via Node-RED, and you can use those very easily. But you can also do direct integrations with Azure IoT Hub or the Google Cloud Platform. And we have generic webhook support. So we have a lot of customers and developers, either when they're evaluating us or building, that will use if this then that to actually pipe data into places like Google Sheets, or to actually work with a tool like Zapier to get your IoT data from one place to another, which is really nice. So the second demo that I want to share very briefly, I hinted at these, or you probably saw them stream by a little bit, but there's a few cases in here where I'm actually using those particle primitives, and this is one area where the firmware is different and unique than what you would see on a typical other Adafruit device or even an ESP32 or something along those lines, is I'm using these primitives, particle publish in this case, to publish a message to the device cloud. To anyone listening, but the device cloud always listens, so I can see those come across, to say, okay, the device has entered a stop state, or the device has entered a forward state, or what have you. But in addition to that, in addition to just particle publish and subscribe, you also have the ability to actually use forward slashes to specify groupings of messages. So if I could do a particle subscribe on the other end that just subscribes to messages with the title rover, and it will send me everything. It's greedy messaging, so it'll send me rover status, or status. I just saw that typo for the first time, rover error, and then it's status correctly down at the bottom. And then I also have a couple of functions to actually run demo and then to stop the device as well. So if you go into the Particle console, which is available at console.particle.io, and then you actually go to the device, one of the quickest ways that you can actually test cloud functions and variables and inspect that these values are coming across properly is actually built into the console itself. Now, if you're using this in a production use case, you're probably intending for this to be executed elsewhere, but this is a nice way while you're in the process of prototyping to actually see that the device says what it's going to do. I'm going to hit it and see if I can get over there fast enough before it knocks off the table, and then wonder if it's even going to work at all after some changes that I made in the hotel. It's not. Wah, wah. Okay, fine. Well, it worked earlier. Y'all saw it. It was proof you saw it, and I got a 1 back, which said that it was successful, so I don't know what happened. But you have the ability to then call, and this would be a time where I would step into my code and find out what the heck I did wrong. I can very quickly debug, do an over-the-air flash, and actually go back there again and see what's going on. So that's all fine and good. And if you're familiar with Particle, if you've used our stuff before, none of this has been particularly new information to you. So what I want to spend the rest of the time talking about tonight is mesh networking and why this matters and why we went down this path of introducing mesh networking into our third generation hardware. And a lot of it really comes down to trying to solve some of the existing weaknesses in connected solutions today. Let's face it, in the consumer space, even in the enterprise space, honestly, Wi-Fi still tends to be the most popular deployment model that's chosen for connected solutions. And most traditional IoT installations follow a hub and spoke model where your Wi-Fi router is your central point to the internet, your central point of access, and it's also your single point of failure. It has two key weaknesses. One is that if a device can't get to the router, well, it's not connected. Doesn't have an IP address, it might as well not exist. It's not a smart device. The other is if, as you hope never happens, your Wi-Fi router catches on fire, you lose your connection to the internet, but really, more importantly for the context of the local network, you don't have a local network anymore in the context of Wi-Fi. Because every individual device on the network loses its IP address and its ability to communicate with every other device on the network. It can't get to the internet, it can't get to anything else. You have, again, still dumb devices. Now, mesh networking takes this concept and does something a little bit different with it by saying that devices should actually have the ability through a gateway to create local networks between themselves, where devices can communicate with one another for the purpose of actually expanding the size of the network to repeat messages between nodes on the network, and a gateway that still functions as that way to connect to the internet itself. But if the gateway or an individual device on the network actually ends up disappearing, that the network can self-correct and heal, and then individual devices or nodes on the network can find another path out to the gateway. That's the whole point of mesh network. In many ways, and those of us that have been around computers and networking for a long time would recognize this is much more of a peer-to-peer networking model than a hub and spoke model like we see in a lot of Wi-Fi installations today. And this is a good thing.
The gateway, in the previous screen you had a dashboard where all the devices were listed.
Yeah.
So are the devices like auto-discovered in the network, like discovery or whatever you call it?
Yeah, I'll come back to the question is on the dashboard on the Particle console, are the devices auto-discovered? I'll talk about that in just a minute. I'll come back around to what that looks like. Because yeah, you do get, even in that console, a view of your local mesh network. So the gateway is what allows the devices to have a presence and be connected to the internet. They can still function when that connection is gone, but they do still have, there's still knowledge about those devices and the state of that network. So, question?
Well, and so just to follow up on his question, the Particle device has two interfaces. One that you might use to get access to the device for programming, and then it's got the mesh interface. And when it is in mesh mode and on the mesh network, does it have the same addressability in the Particle development environment as it did when it was connected through Wi-Fi or Bluetooth or cellular?
Yeah, that's a great question. The question was the mesh devices, if they're in local network mode, do they still have the ability to be accessed as if they were in sort of general internet mode and vice versa? The answer is that they do. And I'll talk about that a little bit more in a few moments. So mesh as a concept is fantastic, and the reason why a lot of providers and vendors haven't gone down this path is not because they don't think that it's great and it's a wonderful networking solution. The problem is that implementing this kind of networking yourself is hard. This is pretty difficult. And the fact of the matter is, for somebody like a Philips that's creating smart light bulbs, it's cheaper just to put a Wi-Fi radio in every light bulb than it is to go down the path of creating your own mesh networking stack. The reason why we even got down to this place in mesh was to actually solve hard problems. But a lot of these things, when it comes to creating your own security and encryption, handling local routing, figuring out how to do local communication via UDP, what kind of radio support you want, how you deal with failover and route redundancy, network addressing roles and responsibilities, all of this stuff is mind-bogglingly complex and not really a lot of fun to tackle. unless you have a very good business reason to tackle it, which the Nest team at Google actually did. The reason why Google went down this path of creating what we refer to today as Thread and Open Thread is because when they changed their business or they expanded their product portfolio to go from from thermostats to smoke detectors, they introduced a new connectivity problem for themselves. Thermostats run on mains power. It's not a big deal. These devices can have a Wi-Fi radio because they're not running on batteries. It's not a big deal. They have a power connection that comes from the wall. They're fine. But a smoke detector needs to run on battery. If you put a Wi-Fi radio in a smoke detector, you're not just going to get chirping every 6 months to a year. You're going to get chirping every 2 weeks. And we all hate changing our batteries on smoke detectors anyway. I can't imagine how difficult that would be. And not only that, but a smoke detector is not a convenience item, it's a safety item, right? Smoke detectors needed to have the ability not just to run on battery power, but to be able to very quickly and safely detect the presence of a fire, detect smoke, and then alert as quickly as possible every other smoke detector in the house so that the residents knew what was going wrong. Now, the Nest team at the time evaluated Bluetooth as the potential mechanism they could use for being that sort of local connectivity instead of Wi-Fi, but because Bluetooth is point-to-point, it didn't solve that problem of them being able to send broadcast messages to all devices on a network or all thermostats in a home. So what the Nest team did is, if you're Google and you have billions of dollars, what do? You invent a new standard and a new solution to this problem, which is what Google did. And they created something called Thread, which is a low-power networking protocol. This was designed to really cater towards smart home scenarios and to low-power devices, which is really what makes it ideal in a lot of IoT sort of scenarios. It's IPv6 based, and the whole idea of mesh is or Thread is creating a wireless personal area network without a single point of failure, and that can be used in concert with Wi-Fi and cellular and Bluetooth. Because that's actually one of the key points that I want to make today. It's not a matter about Wi-Fi versus cellular versus mesh, but whether you're using mesh with Wi-Fi or cellular, or in some cases both, like we'll talk about in a little bit. The whole point of mesh is to actually help to solve some of these problems with Wi-Fi and cellular to bring the costs down in creating networks of devices. And frankly, let's be a little bit honest here. I think one of the problems in the perception the world has of the IoT today is that every device being publicly connected by itself to the internet is a bit of a perception issue. Mesh networks give you the ability to better manage and tightly control access to networks by not giving every device a public addressable IP, but giving gateways the ability to manage connections to the network and creating lower power, less expensive local networks of devices as well. Now, Thread is not the only game in town. There's been a few mentions tonight about LoRa as well, and LoRa is not a direct competitor. I like to mention it in this case because I think LoRa works well with technologies like Thread and Z-Wave and Zigbee when you're going from a local network to networks that need to be coordinated across broader distances. But it's important, since these always tend to come up in comparisons between, to look at Z-Wave versus Zigbee, especially as it relates to Thread. One of the key points here between Z-Wave and Zigbee and Thread especially is that Zigbee and Thread are both based on an open standard, which we feel is pretty important. You don't have to pay a licensing fee just to create a new Zigbee or Thread-based device. And one of the things that I'm really excited about is that the Thread group, the standards body that actually works on the open Thread specifications that we follow and many other vendors follow as well, they actually just released interoperability with Zigbee as well. So you can have local networks, Thread-based networks that can talk to Zigbee devices and vice versa, and actually expand the footprint of those devices as well. I think when it comes to the sort of battle for mesh networking, that combination of Zigbee and Thread really, and the fact that they're both open standards, will really make the difference moving forward. I have like 3 hands up, so that's the first one I saw.
Is there a reason you left Bluetooth mesh off?
Bluetooth mesh, when we first started down the road of evaluating our different standards options, Bluetooth mesh wasn't baked enough and not mature. The good news is that, and also the silicon support is not great. The good news, however, is that as the Open Thread group is paying a lot of attention to Bluetooth mesh and making sure that it interoperates with Open Thread as well. And as that effort continues, we'll have the same capabilities baked into our hardware. In our firmware, yeah. Next question.
One of the things that I've seen talked about is being able to add an external antenna to Bluetooth to allow a larger range for the mesh network. Is that something that's in the plans, or is that just not possible? Or
no, it absolutely is in the plans. The question was there's been some talk about adding an external antenna so that you could get a little bit more range out of the mesh network via Bluetooth, and we do have the plans for that. We're actually also in the midst of implementing all of our Bluetooth APIs inside of the device OS firmware, and that should be coming in the first half of the year, I believe. So you'll not
building it for the APIs.
What's that?
What are they building with the APIs? Just basic serial connectivity and stuff like that, or are they going to do like keyboards, mice, stuff like that, or
all of it, probably?
Wow.
Yeah. I mean, so part of the idea there is so consider it from anything that we've exposed in the Particle Device OS firmware is designed to abstract away some of the complexity of doing things like rolling your own pub sub on an embedded microcontroller, or handling TCP-based cloud messaging and function calls and things like that. We want to do the same thing with Bluetooth. I mean, Bluetooth is a ridiculously complex specification. I've never even bothered to read it, but I mean, thousands of pages of technical documentation around how to interoperate between Bluetooth devices, and we want to strip away a lot of that complexity and make it easy to make connections between Bluetooth devices, to do messaging between Bluetooth devices, and then manage things like connectivity with external antennas and things like that. So, Dan, did you have a question?
Yeah, actually, too. He mentioned the external antenna for mesh, but I think there's already a connector. You can add a second antenna, one for Wi-Fi and one for... So
for the Wi-Fi or the Wi-Fi or cellular radios, there actually is a second port on there where you can add a duck antenna. You can add really add an external antenna. Yeah. And it is a quick switch in the firmware to select the external antenna instead of the PCB antenna that's in there now.
There's an NFC connection too, correct?
So there is an NFC A tag on the boards, but what we anticipate using, we're not sure what those are going to be used for yet. That's part of where customer use cases will lead us down that path of how we expose NFC capabilities on that.
My question on the last slide was, low rod, you had $3 Is that because it's proprietary, or why $3?
The hardware is more. Those dollar signs are more from a pure hardware standpoint. The hardware is a little bit more expensive because you're getting something that's got a lot more power. It's 1 to 3 mile range as opposed to a few hundred feet. So, all right. So I mentioned earlier, mesh networking is reasonably complex by itself. OpenThread's fantastic, and the work that the OpenThread team has done, that the Thread group has done, is really amazing through the specs, defining very clearly for a lot of the vendors out there how you handle creating a Thread-certified network. And this is really what it looks like from a software standpoint. This is everything that you need to know to actually build your own Thread network. So I could actually go out to DigiKey today and go buy a NRF 52840 dev kit from Nordic Semiconductor, and then to set up my own network, once I buy that, I have to manually install their software stack. I have to set up and configure a gateway device, what they refer to as a border router. I have to manually set up and configure one or more routers, child routers on the network, manually set up and configure one or more end devices, and then implement UDP-based messaging between all those devices. So that's what I'm signing up for if I want to create or hand roll my own Thread network. So when people ask me why did we create particle mesh on top of that, the whole reason I believe that particle mesh exists is to take everything here and make it to where you never have to actually see that block diagram ever again. We want to create a situation where creating a thread-based network is as simple as actually pulling out a mobile app, getting a device online, using a command line interface, and then writing simple firmware to communicate between devices and facilitate messaging on a local network. And the way that we do that, the three things that we think really make mesh easy, how we make mesh networking easy with particle mesh, is the thread-enabled hardware. So the hardware you get is thread-enabled by default. You don't have to do anything to turn it on. You have to specify you want a device in a mesh network. But we're using thread-certified radios from Nordic. It's all there. You can use it in standalone mode, but if you want mesh, the devices already have it. And the second is very clear device roles that a lot of times are automatic. If you go and look at the OpenThread spec, and I encourage you to go to the Thread Group website and read some of the basics, because there's some interesting stuff in all the concepts and how mesh networking actually works. There are very discrete roles in a mesh network, from border routers to repeaters to edge nodes to end nodes. And frankly, we feel like for a lot of use cases, we can create some sane defaults. We can take a convention over configuration approach where we can assign some default roles to networks, but then give you the ability to opt out and change those roles if they need to change for some reason. And then finally, simple APIs for communication and managing those networks. So the three roles in the network in Particle's terminology are gateways. Gateways are devices that have a connection to the open internet. But they are not necessarily the only device that these are, unlike a Wi-Fi access point, and this is a very important point to make about mesh networks, a Wi-Fi access point is also in many cases your DNS server. That's not the same, the concept doesn't work the same in a mesh network. Your gateway has knowledge about all the devices on the network, but it's not the only device that has knowledge about the shape of the network and can bring new devices online. Repeaters also have the ability to understand the topology of the network, to understand the numbers of nodes on the network, their next nearest node on the network, to enlist new devices on the network as well. And then critically, they allow you to expand the size of the network by bouncing messages between end nodes and the gateway to when there's too much distance between an end device or an endpoint as well. And then endpoints are your traditional devices. They are the devices that are connected to sensors and actuators and doing the heavy lifting in your network or in your solution. And these are not mutually exclusive. You can have devices that function as repeaters and endpoints. You can have devices that function, you can have a gateway that also is connected to an endpoint device and functions in the same fashion. And then the other primitives that we've added in the context of Particle Mesh is mesh, publish, and subscribe. Mesh PubSub works the exact same way that Particle PubSub does in terms of the shape of its API, but it is purely for local network communication. So whereas Particle PubSub facilitates sending messages up to the Particle device cloud, and then other subscribers not even on that network can then receive those messages and consume them or respond, Mesh PubSub is only for the local network. So this is UDP-based multicast messaging to every node on the network, and it's super, super fast. If you want proof, go to our, I've been fascinated with this idea of the low latency in our mesh and our UDP-based messaging. So you could go to Particle's YouTube channel, and I did some videos late last year of actually creating mesh networked Christmas light displays. So I had a single Adafruit Neo trellis that was basically sending notes across the mesh network to light up NeoPixel strips that were connected to small little mini Christmas trees. And I couldn't see a lag between when I hit a button and when the lights were lighting up, and they all seemed in sync. And maybe I'm just slow-witted, but it seemed really cool to me. So it's very, very fast. And as I mentioned before, the whole point of mesh is not to replace Wi-Fi and cellular, but to make existing IoT solutions and existing connectivity options work better, to work smarter, to be more resilient. So one of the use cases that we talk about in this context a little bit is a case that applies on a factory floor. Yeah, question?
Yeah, as we're talking about the mesh network, is it possible to have a gateway on that network back time?
That's a great question. I have a slide for this at the end. It is in the firmware today. So it is theoretically possible. We don't support it yet currently, but it will be supported in the next month or so, I believe. So, and that's an important point. One of the key network scenarios that we see from customers is Wi-Fi and cellular gateways with failover one or the other. We also have Ethernet support. We have an Ethernet featherwing that you can use in Argon, Xenon, or Boron as an Ethernet gateway, and you can fail over from cellular to Ethernet, vice versa, something along those lines. So, not quite there, but very soon that capability will be there. Yeah. So whether it's on a shop floor, in a basement, what have you, a common use case is devices that may be spread apart. You'd have a smart water meter, a flood detector, and a pump controller, something that turns on a sump pump when water is detected in a basement. One of the cool things about mesh is that a Xenon device is a mesh-only device. I shared the images of these earlier. The Argon is the Wi-Fi device, Boron is our cellular device, and the Xenon has a mesh only radio in that device. It doesn't have a Wi-Fi chip, it doesn't have a cellular chip. It's what makes these devices cheaper. But that doesn't mean that you can't connect those devices to the cloud. So what I showed earlier about calling a function from the console or doing pub sub between devices, you can actually...
Is the radio-only device, sorry, the Xenon?
Well, yeah, the Xenon only has a mesh radio inside of it. It doesn't have a Wi-Fi or a cellular chip.
So that's where the DSR could be.
Inside of it. But even with that, because those devices exist on a mesh network, you can still actually publish data to the device cloud from those devices just like any other particle device. As long as they're connected to their gateway, they can still reach the internet if they need to. They can still reach other systems and applications.
Besides the radio frequency of those devices?
I'm sorry, what?
The radio frequency? So the frequency of the, the frequency. So if it's in a radio-only mode,
yeah.
you have to determine a frequency saying that this is the bandwidth, frequency bandwidth that I will be communicating within the network.
It's at 2.4 megahertz.
So that's again okay, 2.4. So that's wireless only, standard.
Yeah.
Okay.
Well, it's 2.4, but it's narrow like Bluetooth.
It is narrow like Bluetooth, and one of the ways that the Nordic chips have a PHY module that actually handles switching between radios, between Wi-Fi and Bluetooth, or between Bluetooth and mesh, and vice versa. So they have the ability to very quickly interrogate between those.
I had this question like from last 5-10 minutes. I didn't want to interrupt you.
No, that's okay.
You said there is like we can send, communicate, pub sub. Let's say in a PAN. In a PAN, we are doing pub sub. We are using internet and cellular. But let's say we don't want to both. We don't want to use both. We are in a very remote location, in a farm or in a mountain someplace, and we want to use that radio frequency.
Mm-hmm.
Just based on the radio frequency, certain radio frequency, it will say that, okay, this is the bandwidth of the frequency, and then at that frequency, whatever data is being communicated, you should listen. Kind of like LoRa. And I think we were discussing last time a little bit, and we picked up something called DSR, digital signal radio. I don't know if anybody comes to help or correlates or not. We have to.
So this is like a software-defined radio that you're working with? It's actually functioning.
Yeah, I think he's talking about SDR.
Yeah, somewhere, like I don't know where it works.
But I think your radios are tuned in particles. Nordic's chip has radios tuned to 2.4.
Yeah.
So it's not, some vendors and also hobbyists, you can have a radio that you put a down counter in to do clock division, and you can tune it to a particular frequency.
Right. Oh, interesting.
You can grab all of the frequencies in SDR.
Yeah.
But that's not what this is.
That's not what this is.
Okay,
no,
all right.
No. But I'd love to hear more after, and I can follow up with the team and see if there are use cases where...
We don't even know what the use case is. We just came up with an
All right,
idea,
no, I love it. That's okay.
That will be,
That's cool. Okay. Yeah. And so, these devices, you can communicate to the device cloud. You can actually control these devices remotely from the cloud, just like any other particle device. And then critically, and this is the thing that is really most important in why these exist, is if the internet connection is lost, the gateway goes offline, the router goes down, the cell tower goes down, GitHub goes down, and half the internet goes down. These devices can still communicate with one another. So my flood meter can still communicate via the mesh network to the pump controller to respond to something on the local network when it happens without needing the cloud to actually make a decision or tell it what to do. So that's actually the last demo that I want to show. And I have a couple of other devices here that I want to show off. There's two different devices that I have on my desk here, I have an ultrasonic distance sensor. By the way, if you're looking at evaluating the mesh hardware, we actually have, and this is pretty cool, we used to with the photons, we had something called a maker kit. Question?
Well, and it was really before you got to the demo, I have a whole bunch of mesh questions for you.
Yeah.
So you didn't really cover it. So mesh is IPv6, and so your mesh when you do pub sub on a mesh network, that's on the IPv6 network, and I assume your devices have gone into the open thread mode, and they're no longer communicating on the pub sub to the internet except through the gateway.
No, they are. Yeah, they still have the ability. You can do local pub sub, you could do particle pub sub.
Okay, so then the question is, you put a 30 milliamp, which by the way isn't all that low power for a device, power spec on your devices, which a lot of manufacturers that are doing like Bluetooth mesh or whatever have devices that actually go offline and go into deep sleeps and get that down to microamperes.
And you can do that with these. You can do that with the Xenons as well.
Okay, so you didn't go into whether or not you can have a latent node where it's sitting there in basically power off mode in sleep and wakes up based on events that it can detect, and then it gets on its mesh and starts doing pub sub to maybe a gateway and then sends it up and remains very low power so it doesn't drain its battery.
Yeah, so it's an interesting use case. The question is about sleepy end nodes, and that's something that we do support today. I mean, if you can take the Xenons, because they don't have a Wi-Fi or cellular radio, and run those off of coin cell batteries if you absolutely wanted to. Put them in deep sleep mode. They'll run on a few microamps. But your question is, how then can you make those devices wake up? Well, we provide today with all of our devices, the sleep modes that we provide on devices allow you to set up external wake up pins. Every device does that.
That's pretty standard.
Yeah, those are pretty standard.
But I guess what I'm wondering, the ones that have the radio, is the radio the other radio on in the
well, the argons and borons can't go into deep sleep.
See, okay.
So your gateway devices can't. Your gateway devices, or they can. They can. They shouldn't go into deep sleep because then they can't function as gateways.
Well, it should be a simple matter of programming, right?
Sure, everything's a simple matter of programming. Everything's just a simple matter of programming.
Yeah.
Yeah.
Okay, so and now the device software model. If I talk on the mesh pub sub, that's IPv6 pub sub. If I talk off of that, I expect either an Ethernet connection or another radio to get me off of the device. Or can I pub sub on Particle's pub sub to home base through the mesh halfway to a gateway that then pub subs maybe because it's connected or it has better power or whatever?
Yeah. You're talking about just doing a mesh pub sub to a gateway that then does a particle pub sub?
Does the developer have to do that, or does?
Yeah, but that's not. I mean, that's not strictly necessary because you can do particle pub sub from a mesh-only device. And the connection to the gateway is what facilitates its connection up to the device class. So you don't actually have to take the step of knowing I'm an end node, so I can only do a mesh pub sub. You can do a particle pub sub on an end device as well. So you don't have to manually distinguish between those two scenarios.
So how does the device determine which network it talks on?
Mesh pub sub is local only, particle pub sub is to the device class.
So
it depends on the API.
But you just had a scenario where I can mesh through part of the network and then pub sub to the internet.
Yeah, but it's the difference between the network that's being used and the function that's being used.
Correct.
If you're saying that the function call mesh is local, the function call particle is to the particle cloud.
Correct.
Now, which the layer 2 or layer 1 protocol that's used is independent of that. The particle function call knows that it has to attach to a gateway that is proxied to the cloud.
And you don't have to use that. If you prefer to set up your own UDP-based messaging for the local network and then have the gateway do all the cloud publishing, have at it. You're absolutely more than welcome to.
Well, I was going to get in and give you a bunch of, when you say that bridging IPv6 to IPv4 is just a simple matter for the end developer to do, it's not, and that's why you drew that. I know, you drew that picture. You said you could do this or you could get particle. But you set up a straw man because, that thread IPv6 model is on thread because you bought into OpenThread.
Sure.
If you buy into Bluetooth mesh or Zigbee mesh or Z-Wave mesh, then you don't have that difficult because it's a completely different. You're not trying to bridge IPv4. You have to go through a gateway, and you're going to have to do that work.
That's understandable. That's understandable. Yeah. Yeah. I mean, anytime you make a decision like this, you're taking abstractions. You're making abstractions. You're taking things along for the ride. If there are any other questions, we can cover some of that stuff after. I do want to make sure I get to the demo before we finish. So very briefly, I have a couple of argon. I have an argon and a xenon device here that are set up. The argon is functioning as my gateway, and it's sitting in a Grove connector, or a Grove shield, and there's an ultrasonic distance sensor on here. I have another device that's part of the mesh network that's going to be connected in a bit that actually has a 4-digit display on it. And the entire idea of this solution, this contrived mesh-based example, is that I'm reading my distances, measuring in centimeters, my distances from the ultrasonic distance sensor, and then I'm doing a mesh publish of that distance to another device on the network. This is my sensor. It's very simple. All it's doing through the loop is reading those values and sending them along. Now the display, on the other hand, uses the 4-digit display, and then and so here the important piece is actually in setup the mesh.subscribe. So I have the ability to display the distance on the device and then see the distance actually. So display the distance on the device when a message comes across, and that'll show it on the display. So I'm going to plug this in real quick and I'll show you. These devices are only constrained in location by my battery pack and the fact that I don't like traveling with LiPos. Otherwise, I'd put them all the way across the room. I like flying with LiPos specifically. So when this comes on, let me make sure I get it oriented properly. So I can change, and you'll see the messages. Every time it detects a difference, it pops a new message across. Apparently it's 538 centimeters to the ceiling, in case y'all ever wondered. Now you know. The quiz. So 12. So you can see that distance actually changing. But again, these devices are actually, they're connected to the network. I have the ability to see them in the console. So if I see see which one this is. It's not that one. Not that one either. There was a question earlier about seeing mesh networks. So you have, there's a network tab in the console that will actually show you your total device count, the names of your gateway device and your other devices as well. So the display device, so my argon is the sensor device, or excuse me, yeah, the gateway, and then I have an individual node here that's on display. There should be a variable here. Doesn't flash it, that's okay. I could still actually call variables from this device. I can still see events. So if I restart this device, I should see events come across in the event logs. There was a pin reset. So it's still actually publishing messages to the Particle device cloud. But very critically, if I decide to turn off my jetpack, my Wi-Fi access point, in a little bit what's going to happen is my argon is going to lose its connection to the internet. These devices are actually going to start flashing green very soon. So they're no longer connected to Wi-Fi, but I can still change these values, right? So the mesh network is still active. The local communication is still actually happening, even though my connection to the Wi-Fi has been lost. And that, in many ways, is the whole point and why we think the mesh networking is interesting. Yeah, question in the back?
If you had a relatively large mesh network in a commercial space in particular, are there metrics available, or are there data available from the devices as to how the mesh has organized itself? So that, because I'm a network guy. And I just, I look at things like that and go, okay, if the mesh network develops a problem and it's running in its own autonomous algorithms, how do I affect it?
Yeah.
Right. Do I have a device that has a bad antenna? Do I have interference locally in one part that's making the mesh quirky and pushing traffic off in odd ways, things like that?
You want to know how you debug the network, right? How you actually
the actual network itself.
Yeah. So those are features that are still to come in terms of not only understanding the shape of the network topology, but getting access to signal strength. Like RSSI values will be an important indicator of those sorts of things on a network. And so
RSSI is crap. It's quality that matters, but
it's what?
It's quality that matters. I mean, you could have a lot. I can put a signal generator next to you and crank your RSSI through the roof. Doesn't mean you get anything through it.
Right.
I was a network guy, a wireless guy too, but
yeah.
But yeah, that'd be interesting as to how you publish it and whether you pull it out in such a way that would be, easily visualizable, whether in a graph database or your own stuff. Or
yeah. Let's follow up afterwards because it's not something that we've fully implemented yet, but we have some thinking around it. So I'd love to hear what you're looking at, and yeah. Yeah, question.
Also, you say it's fast, but it's fast because you only have 2 devices. But once you have, say, thousands of nodes, then you will have a lot of deterioration in the speed because there you have a lot of redirects that are to reach the gateway. So every time you redirect, the speed is split in half.
Well, which becomes, yeah, so you have the same network design challenges and problems that you have with any kind of network, right? So that's on the onus of the implementer to decide how to shape the network in such a way that the latency is minimized for the right kinds of use cases. There's not, in a lot of cases, you're not going to care that latency is sub-millisecond, depending on what you're doing, but if you need those kinds of speeds, then that should shape the design of your network. Yeah. So in terms of network types, this came up a little bit earlier, but some of the use cases that we envision and typically see is one that I just shared, a single gateway, multiple endpoints. That's going to be relatively common. But as I mentioned earlier, you can have multiple repeaters on that network as well. And then finally, and this is the piece that I cannot wait for us to get out very soon because we know that a lot of people want it, is dual gateways and multiple local devices. So you can have an Argon function as your Wi-Fi gateway, but a second gateway in the boron as well that is either always on or that functions only in failover mode. And so those are things that we are working on.
So I got to ask one question. Do you actually have a connected chicken?
I wish I did. Yeah, no, I don't have a connected chicken. I like to use contrived graphics for those
Well,
things.
I just heard a story on the radio the other day that there are farms in China that are effectively putting Fitbits on chickens.
Are you serious?
So when you buy it at the grocery store, you can get its frickin' life history. So I just wondered.
This is kind of hilarious.
Yeah, look that up.
Have you ever seen? Do you ever see the sketch show Portlandia? Because there was a sketch about this on Portlandia as well, where these people went to this restaurant where they wanted like the dossier from the chicken that they were about to eat, like his name and his life story.
Yeah, no, you get that in certain ones in
like
China.
That's
How do you do that with ground beef?
I don't know.
Food to table. I started, actually, IBM started that, I think. Put food to table, whatever, you know.
The farm to table stuff?
Yes, I think,
yeah.
you know. Farm to table, yes.
Yeah.
Okay, that's one.
Well, yeah, it's a big thing in Austin,
Yeah,
too. Austin's like Portland,
it,
Portland to the south.
They left it, but other people are going with it.
A question in the back?
Yeah, so one of the questions I had was, you know, when we talk about having a multi-gateway mesh, right? You know, part of that is cost. As far as Wi-Fi tends to be very cheap, so you were saying that there's 2 kinds of ways to do it. So you failover mode, and then you have basically you're repeating the same data on both ends from both Wi-Fi and cellular? Or?
No, the devices will decide between each other who's going to handle publishing messages, and you're not sending the same messages to the cloud twice, basically.
So is there an algorithm there in place so that you're limiting your amount of, because cellular is a metered service, and so obviously we want to reduce that as much as possible when we don't need it, although you probably need to have some kind of heartbeat going across to make sure it's still up and active. Are they? Yeah,
but the heartbeat would be between the mesh radio, so it wouldn't affect your data plan and cellular.
No, he's talking about testing the cellular network.
Oh, testing the cellular network. Oh, yes.
So you probably have to ping it every once in a while, right?
Yeah, it's the same way the Electron works today. I mean, you can go in sleep mode on the Electron, but there's an expectation that I think the delay is every 29 minutes you have to do a handshake with a tower.
Right.
Yeah, and it is also like metered, like you said, cellular, you know, like every time we ping whatever, you know, you're using the bandwidth.
That handshake is like 128 bytes.
Yeah, so, but I mean, as far as we're in multi-gateway mode, if the Wi-Fi goes down, or I'm correct that you guys don't support the Ethernet boards yet?
We do.
It does.
You do?
Yes. Okay. We do have Ethernet support, and that's probably going to be the most common use cases. People use Wi-Fi or cellular and Ethernet, because you can use the Xenon as an Ethernet gateway, the cheapest device with an Ethernet shield, and that can actually be one of your gateways.
So can you have three gateways, three gateways?
Huh?
You'll be able to have more than 2 gateways?
Yes.
Okay. Yeah. And then...
And so part of so in terms of how to manage, because I think what you're getting at is how we prioritize messaging and who gets first and what have you.
Yeah, well...
There will be sensible defaults. Like if you have Ethernet and Wi-Fi and cellular, your Ethernet will probably be first. Well, the way the algorithm will work by default is Ethernet will go first, then Wi-Fi doesn't work, and then cellular is your last resort in terms of facilitating messages from the cloud to the network.
And we're expecting that probably by summer, you think?
Yeah. Yeah, so then the other piece of that is giving you the configurability to say, no, 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 I want cellular to be the first, primary, because I have this use case that's specific to that.
Right.
Yeah. So summer, yeah. Yeah, good question. Yeah, and I'm any other questions y'all have, I'm done with the presentation at this point, so yeah.
Can you talk about the organizational structure of Particle, if you will? You know, how many people, how it's financed?
Yeah, it's a great question.
Publicly traded or anything?
So Particle is about 7 years old. We have 130 employees at this point, which is kind of crazy. 2 years ago we had 35, so now it's 130. Particle is private. We're a Series B funded, basically like pre-public company at this point, and are in the midst of going for a Series C fundraise right now. So we have
venture capital.
Yeah, so we're venture funded right now. Yeah, yeah. We have Zach Zapala. The company is actually headquartered in Silicon Valley, in San Francisco. We have about 40% of the company based in San Francisco, and everybody else is either in. We have a small office in Minnesota, which is actually where the company started, and then almost everybody else is remote. So I'm in Austin. Most of our engineering team is spread all over the world. So,
following with Jeremy's question about the gateway.
Mm-hmm.
So, let's say it's a very big mesh network, and since you came from development world, so let's take the load balancing,
sure.
Nginx load balancing, and all those kind of things.
Sure.
So similar thing can be done with your gateway as well.
Mm-hmm.
So failover, scalability.
Yeah.
Yeah, I thought so.
Yeah.
Okay.
Yeah. That's the goal for sure.
That was no point to ask, but just thought.
No, it's good to ask. Appreciate being explicit. Yeah. Go ahead.
So one of the things, I think not a lot of people in this room probably understand this. One of the things that I loved when I got my initial mesh kit was, the feather aspect. And I mention it because I think it deserves its own spiel. But basically, when I got my kit, I could take a particle device and throw it on the back of a 3.2-inch LCD, touchscreen LCD, right, or connect it to a number of other things, and instantaneously you've got this proof of concept. And you can do so many things with that. I think it just is one of the best decisions of the new mesh. We were talking about the mesh.
Yeah.
And I think feather is just as important in the new version 3.
Yeah, I agree, and I appreciate you saying that. I probably need to linger on that one for a few more minutes in presentations in the future, because it is one of the things that I was most excited about when we first announced it, because it is. I think when we announced it, there were 50 feather wings. Now there's somewhere like 60, 70. I mean, there's a lot. Anything that you can potentially think of, as well as doublers and triplers that allow you to very easily interconnect these different boards together. And to your point, it's perfect. I mean, having the ability to slot, one of these boards into Adafruit's robotics platform or into a TFT display or something along those lines is a really powerful feature. And the reason why we did that was because we feel like that makes prototyping easy. I mean, one of the things that the whole point of having dev kits in the first place is not for production use, it's to help you build a prototype faster. And right now the industry seems to be sort of congealing around this idea of the featherwing form factor as the easy, accessible way to do that. So we jumped on it happily. Which is cool. Question?
Yeah, can the current ecosystem talk to just a standard Bluetooth device?
So what do you mean? What do you mean by standard Bluetooth device? I've never met one.
So we have a situation where we love to use the Argon as like our hub that goes out to the world, but then we have a very small device that's the size of your thumb that already has a
BLE device? Is it at least a Bluetooth 5 device?
Yeah.
Okay. Yeah. So I mentioned a little while ago that we are working on Bluetooth APIs to launch around Q2. And those Bluetooth APIs would allow you to facilitate connections between non-particle devices. Yeah, that's part of what. I'm glad you mentioned that, because I wanted to be. That's important as well.
Yeah, I want to thank Brandon for tonight. This was like awesome meeting. Particle is like one of my favorite companies. Thank you. And I know there's some of you that still have questions, so after we turn off the YouTube channel, come back up, ask Brandon more questions, and we've got, like, we could talk particle all night.
Yeah, I know.
Me too. And Jeremy asked a good thing, or brought up a good point with the feather wing. And like what we did with the stretch wrap company, we were able to buy a whole bunch of commercial off-the-shelf products. It's like we added our gateway. We wanted to queue up messages when we lose our connections. So we got a feather wing that has an SD card on it. Then we have an HMI. We got a feather wing with a 7-inch HMI a display for it. So it's like you can get all these commercial products and really quickly make a prototype and be testing in months, which is what used to take like a year or something like that to do.
Yeah.
So there's nothing more productive to me than Particle for getting prototypes done and quick and awesome. So
cool.
I'm really
Thank
stoked
you.
that you came to us tonight.
Thank you.
Thanks for making the trip.
Yeah.
Well, thank you, Dan and Brandon, both of you, man.
Oh, yeah.
Thank you.
Yeah, awesome. Thank you. And that's pretty much it for tonight. Hope to see you guys next month, which is going to be helium, which will also be awesome. Don't miss that.
Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.